So let's try and solve this challenge. It says closest elevator, and it says given two elevators named left and right in a building with 3 floors numbered 0 to 2, 0, 1 and 2. Write a function elevator accepting 3 arguments in order: left being the current floor of the left elevator, right the current floor of the right elevator, and call the floor that called an elevator. So it should return the name of the elevator closest to the called floor, and it should return either left or right. In the case where both elevators are equally distant from the called floor, choose the elevator to the right. So you can assume that the inputs will always be valid integers between 0 and 2. So these are examples. We have the left, right, and the call as a floor, which it was called. So in this case, we have the result as left. And the reason because the call is on the same floor with the left elevator, and the right is above that. So the same with this, we can see that the call is on the same floor with the right, so it's right. So the elevator, we can also see here that the call is just above the right, and the right is above the left. So the right is closest to the call. But in this case, they're all on the same floor, but priority is given to the right lift, so it will be right. And here we have the call is at the center, the first floor, and the right lift is at the top, and the left lift is at the bottom, but priority is given to the right lift. Let's look at conditions that will favor the left lift, because I think it has fewer conditions favoring it than the right lift. So let's isolate it to the left. So let's try by creating the condition. So I'll say condition 1 that way, and the first condition is the left lift will be called. So let me just put this in comment and say conditions that favors the left lift. Yeah, condition that favors the left lift. So we have this as first condition, and the first condition will be when the left lift is on the same floor with the call, where the call was made, and the right lift would not be on the same floor with where the call was made. So in other words, when the left lift is exactly on the same floor that the call was made, and the right lift is not on that floor, then the left lift will be called. And we can see the example here where the call was made on the ground floor, and the left lift was on the ground floor, but the right lift was on the first floor. So once this is true, then condition 1 will pass, and that means the left lift will be chosen, right? So let's look at another condition where the left lift will be chosen. So I'll call that condition 2. And the second condition, I believe, is when the call is on a lower floor than the left lift, and the left lift itself is on a lower floor to the right lift. So this is very easy to understand. Now the left lift will be closer to the call, where the call was made. So, and the right lift is above the left lift. So the left lift should be called, because assuming the right lift was in the same floor with the left lift, then priority will be given to the right. But since the left is closer to the call, then the left lift will be called. And I think the last condition will be the other way around. So condition 3 would now be the other way around, where the call is above the left lift and the left lift is above the right lift. So I think these are the three basic conditions that would favor the left lift to be called, right? So if this is to pass, then we are going to return left, else then we'll return right. So let me just do just the if statement, and I'm saying if condition 1 is true, that way, or condition 2 is true, or condition 3 is true. So if they return, any of them return boolean true, then we are going to return the left, that the left lift will be called, right? Else we are going to return the right, because the right is more favored to be called than the left. So what we've done is basically we've analyzed three conditions where the left lift will be called, and besides that, then the right lift will be called. So let's test that. And it's passed, and let's attempt, and good, we've passed all our tests. A way to refactor this is using the ternary operator. So instead of using if else here, I can just say this condition, if this condition is true, then I want to return left this way, else I want to return right this way, right. So I think this should also pass. So test. Now it's failed, and let's see the reason why. Oh, because we've not put the return. Remember, we have to return that. So let's return it. Passed, attempt, and pass. So we've refactored that using ternary, but there is a better way to refactor this to even make it shorter. And what's that? If we look at these three conditions, we can see that the distance between the left floor and the call is lower than the distance between the right floor, that's the right lift floor. So let's go back to the example we are given here, and we can see that in this case, where the left was chosen, the left itself is on the ground floor and right is on the first floor, and the call is on the ground floor. So if we subtract this from this, 0 minus 0 is going to be 0, right? But if we subtract this from this, 1 minus 0 is going to be 1. 0 minus 1 will be minus 1. So if we find the absolute value of that, whether it's 1 minus 0 or 0 minus 1, we'll still get 1. And 1 is higher than 0. So we can say that when the left lift floor is closer to the call, where the call was made, than where the right lift is, then the left will be favored, because it fulfills this situation here. Because if the left lift and the call floor is in the same place, and the right is not, that means the right is either lower or higher, then it means that the left is closer to the call than the right. That's just what it means. And if you look at this here, we can see the same thing, that the call is lower than the left, but the left is lower than the right. So it means the left is closer to the call. So imagine the call is on the ground 0 and the left is 1 and right is 2. So it means that the left and call will just be 1, difference of 1 floor, and the right and to the call will be difference of 2 floors. So this passes too. And the third one is the left is also closer to the call than the right left, right? It's the same thing. It's just left is one floor above and the right is like 2 floors above. So we can summarize all this into one statement, and that's simply subtracting the difference between the call and the left and comparing that and with the call and the right, difference between the call and the right. So let's do that. So I'm going to take all these ones off, and I'm just going to do it within this one statement here. So instead, I'm going to compare the absolute value. So absolute definitely is Math.abs to find the absolute value, and then we're going to say call minus left. So if this one is lower than, we'll find the math absolute value 2 of the call minus right. So if this is lower than this, then left to be chosen, else right to be chosen, because this statement here replaces our 3 conditions we had before. So let's test, and it passed, and let's attempt, and it passed. So that's basically how to refactor this and to solve this in JavaScript. So let me do that in Python and see if we'll get the same results. So now in Python, we are given the same thing, and I'm just going to use the same process to do that. So I'm going to say condition 1 is going to be equal to when the left is on the same floor as the call, where the call was made, and now we don't want the right to be on the same call at the same time, and so we'll say not right is equals to call. So that's condition 1. Condition 2 is when the call is lower than the left, right, and the left is lower than the right. And condition 3 we had is when the call is higher than the left and the call and the left is higher than the right. That way. So when we have these 3 conditions fulfilled, then we can, the left will be selected, else the right. So I'm just simply going to then return. Say return, and you know we use if else in Python, so it's going to select the left if, and we're going to pass these 3 conditions. If condition 1 is true, or condition 2 is true, or condition 3, now this is condition 3 is true, else it will just send back, it will just select the right left. So this is similar to what we did in JavaScript, and if we test that, it works. Attempt, it works. So let's use the absolute method to solve this the same way we did with JavaScript. And what we said was that the distance between the left floor and where the call was made is always in these conditions are smaller than the distance between the call and the right floor. So we can just summarize all this into using the absolute statement here. So we'll just say absolute. So here absolute is detached from the math, so you don't need to import the math module. So absolute, then we are going to say the call minus the left is lower than absolute of the call minus pass the right. So that way, else, right? So this should pass basically. So we can